Projectile motion, as we already know, refers to the motion of an object thrown into the air under the influence of gravity. Now, our focus here is to be able to solve any problem at all related to any type of projectile motion. But there's something strangely beautiful about this motion type, but also deceptively confusing. People tend to treat it as it visibly appears. But what if I told you projectile motion is an optical illusion? Yes, you heard me right. It is actually an illusion of two distinct kinds of motion being performed simultaneously. One, vertical motion under gravity, and two, constant velocity linear motion. Let's consider the Earth for a second. Imagine the Earth as a flat surface. Gravity always acts perpendicular to it. That might sound obvious, but here's the twist. This is mathematically true. No matter how an object is dancing under gravity, gravity is always acting straight down. Surprisingly, this means that projectiles are also performing vertical motion under gravity, at least in disguise. So, we're pretty much convinced when it comes to the vertical motion aspect. But how can we prove the second hidden motion too? The constant velocity part. The part that's also performing in disguise? Well, don't worry. I invented a projectile motion shadow separation tool for you. So it works this way. We'd need two surfaces that stand at a right angle, and two sources of light, one pointing on the horizontal surface, and the second on the vertical surface. When a bullet is projected from the origin, the lights convert the moving path to its original frame, being experienced by the shadow cast on the vertical or horizontal surface. We get the shadow on the vertical to encode motion under gravity, while the horizontal shadow encodes constant velocity. Proved! But why must the horizontal shadow move at constant velocity, unaffected by gravity? Well, it's because gravity does not act along the Earth's surface, only perpendicular to it. Now that we know these hidden motions, we have the key to be able to solve every projectile. Here's the idea. For any projectile problem, you're indirectly being asked about one of two directions, any of the two shadows. Maybe it's, say, the maximum height, and that hints at the vertical shadow. But here's where most people get lost. They try to mix the two, vertical and horizontal questions, without noticing. Now, let me quickly clarify this fact real fast. Let's say you're aiming a shot at some angle theta with speed v. You might be tempted to play it straight. But wait, neither the vertical shadow nor the horizontal shadow moved at initial speed v. That initial velocity they were shot with was cut into v cos theta and v sin theta, horizontal and vertical components respectively. Let me know in the comments section if you'd need a proof of why we use the trig identities in the initial velocity separation. Now proceeding, these shadows are two different levels. They don't share direction. They don't share velocity. They only share time. That's it. So if you stay in one shadow's world, say the vertical, you can safely use the three kinematic equations you already know, substituting v for vy. You don't bring horizontal data into the vertical world and vice versa. They just don't mix. So what do you do when you encounter a missing value, say distance, in any of the two different worlds? That's when time comes in. Time is the bridge. You just draw an equation that says time elapsed by vertical shadow equals time elapsed by horizontal shadow. Most questions would leverage time to play tricks on your mind. But notice that whatever time the vertical shadow takes, it's the same time used over the horizontal shadow. That's what makes them successfully overlap in real time. So, say you calculate the time to reach the maximum height and back to the ground using the vertical shadow. Great. You can now plug that time into the horizontal shadow equations to find the range. This is because, by the time the vertical shadow travels forth and back, the horizontal shadow has covered its range exactly. Also, you might use the horizontal motion to find how distant the object is in the air when you know the time the object elapsed horizontally. Don't mix them, don't confuse them. Just pick one. Solve everything possible inside that world. And when you want to cross the bridge, let time lead the way. Please support us by liking and subscribing if the video just opened a key to projectiles. Have a nice day.